Hi everyone, welcome to today's tutorial. So in this tutorial, we're going to discuss how we can use the definition or the first principle to find the derivative of these given functions. So if you have not yet subscribed to the channel, make sure that you click on the subscription button and also click on the notification button so that the videos that I'm going to be posting would be popping up on your screen and you'll be able to get notified that there's something that has been posted on the channel. And if you have any questions, feel free to contact me using this same line, these lines on the screen. Okay, so this is a very simple question. Yeah, so it's a very simple question. One thing you just need to understand is the first principle or the same so-called definition. Yeah, so we know to say if you've been given f of x, then they are asking you to find f prime of x. Using the definition, you always have to find the limit as h approaches 0 of f of x plus h minus f of x, everything divided by h. So this is what you're supposed to use to find the derivative of any given function. So let's take a look at the first question there. So the first question, we have f of x being equal to x plus 1 over x. So we can simplify this if you want to x squared. When you find the common denominator, so the common denominator will be x, then on top there we'll have x squared plus 1. Yeah, so this is our function. This is the one that we're going to use to plug into that. So if we say f of x, if for instance we say f of x is equal to x squared, if I say f of 1, the answer is 1 to the power 2. Yeah, so what I'm trying to explain is this part here. So f of x plus h is simply just found by replacing x plus h where there's x. So we say f of x plus h, we'll put x plus h where there's x, so we say x plus h there. And then we say squared. So that's what that means. So this simply means that where there is x in this function, we're going to put x plus h in this expression. So to find f prime of x, we're going to have the limit as h approaches 0 of, so f of x plus h, we'll put x plus h there, so we have x plus h squared plus 1, everything over x plus h. And then we say minus f of x. So f of x is simply just that same function. So the same function there, we can say it's yeah, so we say it's x squared plus 1 over x, and then we say everything divided by what? By h. Okay, so now what we are supposed to do here is just simplifying this part here. Yeah, so this will become x prime, f prime of x being equal to, we find the limit as h approaches 0 of, so when you simplify this, we're going to have x squared plus 2xh plus h squared, then we have plus 1, then everything over x plus h, then we say minus x squared plus 1 over x. Then we can simplify this fraction. So we can simplify this fraction. Let me just create some space here. Okay, so how do we simplify that fraction which you have there? And of course, I've forgotten to put the denominator h. So everything has, everything of the denominator h. Okay, so we find the common denominator. So we have f prime of x being equal to, so we have the limit as h approaches what? 0. Then the common denominator this side is going to be what? x times x plus h. Then when we also divide by h there, it means that we're going to have h somewhere there. Okay. So, or maybe before we do that, let me just leave the h alone. Then on top there, we're going to have this into that, it's x. X times everything on top there, we're going to have x times x squared. That will be x to the power 3. X times 2x, h. We're going to have 2x squared h. Then x times h squared there, we're going to have xh squared plus x. And you say minus, minus. When we say x into this expression, we're going to remain with x plus h. Then we multiply it with x squared plus 1, and that will give us x plus h times x squared plus 1. Okay, so now if we divide by h, it means that the h will be there. This is the h I'm talking about. So I'm still simplifying this expression. So f prime of x is therefore going to be equal to, so simplifying the numerator there, we're going to have x to the power 3 plus 2x h plus x h squared. Here there's supposed to be squared plus x minus. So when you simplify this expression, we're going to have x times x squared, we have x to the power 3. X times 1, we have x. H times x squared plus hx squared. H times 1, we have h. We're dividing everything by x, h, x plus h. Then of course here there is the limit, there is this part here, as h approaches 0. So our f prime of x will therefore be equal to, so you can see that x cubed minus x cubed will give you a 0. Then we have 2x, we have 2x squared h, 2x squared h, okay, 2x squared h minus x squared, x squared h. The answer is simply just going to be hx squared. Okay, and then we have this part here, which is xx squared plus xh squared. Then we have plus x there. So plus x and this x there, this x minus x will cancel. So we'll just remain with h this side. And of course there is a minus here. So minus h will be there. And then the other part that we have not checked is, okay, even this one is subtracting because we have xh squared there. And okay, they're different. I thought it's going to subtract with this one. So we can just write it there. Okay, see, it's already here. It's already there. Then this part is the one that's subtracted with that. Okay, so this one and that, this one is there. This one has cancelled with that, that, and that. Alright, so we're dividing everything by h. Then we have x and x plus h. This h and h and h and h will cancel. Of course, we have the limit as h approaches 0. So we're just going to remain with the limit as h approaches 0 of x squared plus x, xh of course, because one h has gone, that's cancelled with that, then minus 1 over this h has been cancelled, we've just remained with x, open brackets, x plus h. So we create some more space there. Okay, so this is now easy to simplify. Okay, it's now easy. So what you just need to do is to replace 0 wherever there is x in this expression. So we put 0 there and 0 there. Therefore, our x prime of x, rather, f prime of x is going to be equal to x squared plus x times 0 minus 1, everything over x times x plus 0. So the solution will therefore be x squared plus 1 over, because 0 times x will give us a 0, then over x times x. So our f prime of x will therefore be equal to x squared plus 1 over x squared. Okay. So this is the solution. So you can prove this even by using the power rule. Let's see if this answer is correct. So using the power rule, we know that f of x can also be written as x plus 1 over, okay, this one over x can be written as x to the power negative 1. Okay. Oh, sorry, there's supposed to be minus 1 here, not plus. This is supposed to be a minus. Yeah, so there's supposed to be a minus there. Okay, so let us now simplify, use the power rule to solve this. So the derivative of x is 1, then we say the derivative of this part will be negative x negative 2 there. So we can write this as 1 minus 1 over x squared. So this can also be written as, the common denominator is x squared, x squared times 1, that will be x squared there. Then we have minus 1. Is this the same as that? Yes, meaning we have gotten the answer correct. So we move on to the next question. So the next question is g of x is equal to 4 over the square root of 1 minus x. So this one is also straightforward. So using the definition, we know to say the definition states that our g prime of x is going to be found by finding the limit as h approaches 0 of f of x plus h minus f of x, then everything over h. Okay, so our g prime of x is therefore going to be equal to f of x plus h. We replace x plus h where there's x in this function. So we find the limit as h approaches 0 of 4 over the square root of 1 minus x plus h. And then we say minus 4 over the root of 1 minus x, everything being divided by h. Okay, so our g prime of x is therefore going to be equal to the limit as h approaches 0 of, so let me just do this. So simplifying this, we can write this as, or we find the common denominator there. The common denominator will be the common denominator is going to be this times that, which is just the same as, okay, so the common denominator will be this times that, which is just the same as multiplying what is inside there times that. Or if you want, you can just say the square root of 1 minus x plus h times the square root of 1 minus x. So this is what we have. And then everything is being divided by h, this h here. So on top there, we're going to have this 4 times that, or we say this expression into that, it's this part that will remain. This times 4, we have 4 root 1 minus x, and we say minus 4 root this part 1 minus x plus h. So what I've done is this into that, we remain with that times 4, this is what you get. And then everything divided by h. Okay, we create more space so that we can solve the other questions. I mean the remaining part of the question. All right, so we can simplify this. How do we simplify this? Simple. So what do? We find the conjugate of the numerator there. So this can also be written as open brackets. The 4 will be factorized out. So we find this 4 times that will times everything in the brackets there. I'll get back to the expression that I've just changed, where you also have 4 here. Okay, so we can find the conjugate of the numerator. So how do you find the conjugate of the numerator? So the conjugate will only be found by changing the sign in between there. So this means that we're going to have x prime of g prime of x being equal to the limit as h approaches 0 of 4 times the root of 1 minus x minus the root of 1 minus x plus h. So we find the conjugate of that. So the conjugate of the numerator there will be the root of 1 minus x plus the root of 1 minus x plus h. Then everything we divide by, we have the root of 1 minus x plus h in brackets. We also have the root of 1 minus x. And then we have 1 minus x plus the root of 1 minus x plus h. Okay, so g prime of x will therefore be simplified as, so on top there, if we multiply this and that, if you multiply this and that, this is just the difference of 2 squares. It's just the same as squaring the first part and the second part. So this is just the same as writing 4. So we have the limit as h approaches 0 of when we have x plus y times x minus y. This is just the same as x squared minus y squared. So this is what I'm saying. It's just the same as squaring this part and also you square that part when you multiply these two. So if you do that, when you square the first part, this part here, when you square it, you're just going to remain with 1 minus x. Then when you square this other part, we say minus. When you square this other part, you have 1 minus x plus h. Okay, so this is what you're going to have. And then the denominator there, when you multiply this first part times everything there, you're going to get 1 minus x. This and that will give you 1 minus x as the solution, because we know to say the root of x times the root of x gives you what is inside, which is just x. So the root of 1 minus x times the root of 1 minus x will get that, and then this times that. And don't forget that all these expressions are being divided by h. Okay, so multiplied by that, and then this part times this, we're going to have what is inside there multiplied by that. So we say plus what is inside there is 1 minus x plus h times the root of 1 minus x. So this is what you have. So our g prime of x is therefore going to be equal to, so we say 4, and then open brackets, you have 1 minus x, then minus 1 there. When you open the brackets, you have minus 1, then plus x, and then plus h. Okay, then down there, everything here is also being divided by h. So down there, you're going to have this same expression that we have, but multiplied by h. So we have h there, and then open brackets, we have x minus 1 times, so let me do this, times the root of 1 minus x plus h. Then we say plus 1 minus x minus h. When you open the brackets here, negative 1 times x, negative x, then here negative h as well. Then we're multiplying this by the root of 1 minus x. Okay. So we proceed. So we can proceed with that. So we have g prime of x being equal to, so when you simplify the numerator there, you find that 1 and negative 1 will cancel, negative x and positive x will cancel, so you just remain with positive h on top. So you have h on top, down there you have h times everything down there. But if you check properly, this h which is down will come and cancel with that h. Anyway, let me just write what I'm trying to say here. So we have x minus 1, and then we have the root of 1 minus x minus h, plus you have 1 minus x minus h root 1 minus x. So this h and that h will cancel, so that you just remain with what I'm going to write here. So our g prime of x is therefore going to be equal to, on top there will just remain with 1. And so on top we're just going to remain with 1, and then down there you're going to have this expression, which is x minus 1 times the root of 1 minus x minus h, and we say plus 1 minus x minus h times the root of 1 minus x. Okay. So from there now we can write the final answer. And I've been forgetting to write the limit as h approaches 0. The limit as h approaches 0. So we can find the limit of this expression. So we replace 0 with this h. So if you put 0 there and 0 there, you're just going to remain with 1 over. And so we're just going to remain with 1 over x minus 1 and the root of 1 minus x. I don't know where I'm getting this x minus 1. It's supposed to be 1 minus x. Okay, it's supposed to be 1 minus x. And even here. So it's not supposed to be x minus 1, but 1 minus x. Okay, so when you put 0 there, you also have 1 minus x, then times the root of 1 minus x. So this will give you 1 over 2. So this will give you 1 over, because when you add this and that, since they are the same, we're going to have 2, 1 minus x times the root of 1 minus x. Yeah, so this is what it means. So if you want, you can simplify this further, or if you want, you can leave it like this. Yeah, so you still have the same answer. I mean, the answer will still be the same. If you want, you can simplify this further by combining this and that. Because when you're multiplying numbers with the same base, you always add the power. So the power here is 1. The power on this other 1 minus x is half. So when you add 1 and half, you get 3 over 2. So what I'm trying to say is, the final solution will be g prime of x is equal to 1 over 2. And then you get 1 minus x to the power 3 over 2. It's still the same. Okay, so let us try to use the change rule or the quotient rule to see if the answer that we've gotten is correct. So we have g prime of x being equal to 4 over, oh sorry, I forgot there was a 4 outside, so on top here it's not supposed to be 1, it's supposed to be 4. There was a 4 outside which I forgot to multiply with the 1, with the h that was left as a numerator. Sorry for that. Okay, so we have on top there's supposed to be 4. So we have 4. Let me just do this. So we have g of x being equal to, it can be written as 4, open brackets 1 minus x to the power negative half. So simplifying this, we're going to get so simplifying this expression, or finding g prime of x using the chain rule, I said g of x is equal to 4, then 1 minus x, close brackets, to the power negative half. So this can be found by using chain rule as 4 times differentiate what is inside there, you get negative 1, and then multiplied by the derivative of this expression, which is 1 minus x to the power negative half minus 1, that would be negative 3 over 2. So g prime of x is therefore equal to negative 4. Of course, we're supposed to divide by 2, because you drop down this, you multiply this negative half times 4, that would be negative half times 4, that would be negative 4 over 2, and then this means that this negative and that negative will cancel, meaning we'll have 4 there. So I'm just trying to use the shortcut of chain rule to prove if what we got was correct, if this is correct. Yeah, so we have positive 4, and then we have 1 minus x to the power negative 3 over 2. So g prime of x is therefore going to be equal to 4 on top, and then the denominator there will be, the denominator is therefore going to be what? It's therefore going to be, because this is negative, so that's going to be 1 minus x to the power what? 3 over 4. Oh, sorry, 3 over 2. Yeah, so you can see that what I've found here is exactly what we found there. But of course, there's a 2 there, which I've forgotten to write even here. So you can simplify this 2 into 4, so meaning on top you just have a 2. Okay, so even here you can simplify. Okay, so this is the solution. Let us quickly do the last part. So the last part is h of x is equal to x squared minus 8x plus 20. So Using the definition, our h prime of x will therefore be found by finding the limit as h approaches 0 of f of x plus h minus f of x over h. So our h prime of x will therefore be equal to the limit as h approaches 0 of, in this expression where there's x, we're going to put x plus h. So we have x plus h squared minus 8x plus h plus 20, then minus x squared plus 8x, sorry, there's a minus there, so we put minus, then plus 20, then everything we're dividing them by h. So our h prime of x therefore going to be equal to the limit as h approaches 0 of so when you simplify this part, we're going to get x squared plus 2xh plus h squared, then minus 8x minus 8h plus 20, then negative times x there, negative x squared, negative times positive x, positive 8x, we have positive 8x, rather negative times negative 8x, positive 8x, negative times 20, we have negative 20. So as you can see, this 20 and negative 20 will cancel. Positive 8x and negative 8x will cancel. We have x squared, negative x squared, and that x squared will cancel. Of course, this is divided by h, and what we're just remaining with is this expression here. So let me write it here. H prime of x is equal to the limit as h approaches 0 of 2xh okay, 2xh, then plus h squared, there's this h squared, and we have minus 8h. What else is remaining? Nothing. So we're dividing everything by what? By h. So h will cancel. We're just going to remain with the limit, or I mean as h approaches 0 of 2x plus h minus 8, everything over, oh, nothing, the h has been cancelled. So we just replace where there's h, we put 0 in this expression. So our h prime of x will therefore be equal to, while there's h, we put 0 there, so we'll just remain with 2x plus 0 minus 8. So our h prime of x is therefore going to be equal to 2x minus 8 as a solution. So this is the final answer. So these questions are simple and straightforward. Yeah, so in case you have some more questions, feel free to contact me on any of these lines on the screen. If you want to join tuitions or tutorial sessions, you can also contact me using these same lines on the screen. Don't forget to subscribe to the channel and click on the notification button so that you don't miss out the videos that I'm going to be posting always. Okay, my name is Amted. See you in the next tutorial video. Shalom, shalom.